There are a lot of different objects in the night sky, such as stars, galaxy, and nebula. We can take a closer look at these objects using telescopes. Let's take a picture of a galaxy. The light from the galaxy is collected by the telescope and sent down to a camera. The camera is made up of lots of little buckets called pixels, which collect the light. Some pixels are collecting the light from the galaxy and are getting lots of light. Other pixels are collecting light from the dark background and not getting much light at all. And some pixels are collecting light from somewhere in between. Once the camera has finished collecting the light, we can take a look at the pixels in a grid and see how much light was collected in each. For our galaxy observation, we can see the image contains some very bright parts where the pixels collected the most light, and some dim parts where the pixels didn't collect much light. The amount of light that was collected translates to the brightness of the pixel in the image. In our grid of pixels, we can also take a look at how many collected lots of light, and how many collected only a little light. This information will help us make adjustments to our image later. In our simplified example, we can see there are a range of values from 1 to 16 in the grid. If we take a closer look, we can see that there are a particularly large number of 3s in the grid. Let's collect those together and count them up. We can do the same for the 4s and see that there are quite a few of them, but not as many as there are 3s. And if we continue collecting the different numbers together, we can see that there are even fewer 1s, 9s, and 16s, for example. With all the numbers collected up, we've created a graph called a histogram. This histogram shows us how many bright pixels there are, how many medium pixels there are, and how many dim pixels there are in the image. One interesting thing you might notice in our histogram is that there aren't any pixels with a value of 0. Why is this? Well, the sky is not perfectly dark. Even if we can't see a star or galaxy there, we still get a little bit of light from those dark areas of the sky. So, why is a histogram useful to us? There are many reasons, but we'll focus on just one. In our example, the histogram will allow us to adjust the image so that different parts of the galaxy stand out more depending on what you're interested in seeing. This is done by adjusting the black and white levels. We can set how bright the blackest pixels in our image are. We can set how bright the whitest pixels in our image are. And we can set how bright the middle pixels in our image are. If we set the black triangle too low, the image becomes very gray and washed out. If we set the black triangle too high, the image becomes too dark and we can no longer see the dim parts of the image. Usually, it's best to leave the black triangle somewhere on the left-hand side of the histogram. If we set the white triangle too low, the image becomes very bright and washed out, losing detail. If we set the white triangle too high, the image becomes very dim and we can no longer see the dim features in the image. Where you set the white triangle depends on what features in the image you want to see. Once you're happy with what you've positioned with your black and white triangles, you can fine-tune your image by making small adjustments using the gray triangle. Moving it a little to the left can help show dimmer features, and moving it a little to the right can help show the brighter features. There is no right or wrong position to have these triangles. It's all about what you would like to see in the image. By using the histogram to adjust your image, you will be able to make a number of different looking images based on the original data from the telescope. Perhaps you might like to make one that shows the dim features in your galaxy or nebula. Perhaps you might like to make one that shows the bright features, or somewhere in between. Whatever you decide, the histogram is a very useful tool to make the image just how you like it.